Hi, in this question, I'm going to solve practice question for introduction derivative data. So we need to describe the correlation shown on each scatter diagram. Number one, we are going down, which is close to others, to the baseline. So here we can say this is a strong negative because going down correlation. So the more hours, of watching TV, so it's gonna be the less the test. The test. Let me write it properly. The test score. B. Okay, as B is going up and the diagram is close to each other, so this is a strong positive correlation. So the longer the length, the longer the length of arm, which is here, it's gonna be the higher the bowling speed, which is here, the higher bowling speed. Okay, see, we can see here we cannot describe is it going up, going down, it's gonna be random, so we can write it as this is zero correlation. So the demand of bird here, demand of bird has no effect on mass here, on the mass. So the demand and the mass, there is no correlation. Okay, we'll go T. Okay, here also going down and close to each other. So here is a strong negative okay, let me write it down. Correlation. So the more cigarette smoke daily here, the less of the length of life. Less of the length of the life. Okay, shoe size and then the height. Okay, here also going up. This is not that strong. Yes, okay, can say strong also, as this is close. We can write a fairly strong positive. Okay, strong positive correlation. So usually the taller one is, so the bigger is the shoe size. Okay, let's take a look number 2. We need to copy and draw copy the diagram. Okay, let's use this and draw the line of the base speed on it. So we need to use a ruler. Here is my ruler. The tips is line should be when we make it base speed, so not we try to as much as close to make it equal, not too much before or after the line. Okay, here it is. We can draw it. Okay, let's see how many are there. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, here you can draw it. Okay. Here is to draw the base pin. And then B, use the base pin to estimate 165. Okay, 165. See, 165. 5, 5, 6, 7, 8, 9. Okay, here is 4.7. So approximately here is approximately equal to 4.7 meter. Next, for the age of a circuit school team, the record for long jump is 6.07. How tall would you predict the student would be? Will be to, okay, 6 point. Yeah, 6.7. So how tall you predict? So here's more than 6 points. So we can start from here, the higher. So between 180 and 185 centimeter. Explain whether you think this is reliable prediction. So actually this is not the reliable prediction because, yeah, because 6.07 is beyond the range of the given data. So let me write it here. Not reliable because 6.07 is beyond the given data. Okay, D, we need to, okay, look at it. They are going up, but they are not too close to each other. So the correlation is weak, positive. So what does the correlation indicate about the relationship between height and the distance jump in the long jump event? So the taller athlete, let me write it here for E. The taller athlete can generally jump further. Okay, there it is. Number 3. Okay, what is the dependent variable? Dependent is here the distance. So A is the distance, M. Plot a scatter diagram. Okay, so we need to draw it. Use a ruler. Okay, start from 0. Here it's gonna be 100. 2, 300, 400, 500 and 600. Let me mark. It's 100, 100, 200, 300, 400, 500 and here 6. I can make it from here. Okay, 400. Okay, then next we will make it the age of the year. Let's count it in 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and let's make it until 16 here. Here the red color. Okay, so started with 2, and then 4, 6, 8, 10, 12, 14, and 16. So here is the age, which is years. Next, count it in 100, 200, 300, 400, 500, and 600. So here is the distance meter. So let's start. When the age of 12, the distance is 200. So 12 and 200 is here. Let's plot it. Next, when the age of 8 is 350. So 350, let's plot it. Okay, next, when 7, the age, let's make it draw the straight line. So here is 600 line. Here is 500 line. Here is 400 line. Here is 300. If you have a grid, it will be better. Against the grid is 200 line. Okay, next let's make it the grid for age of year. So as I say, if you have a grid, this will be better. So 2, this is S4, 6, 8, 10, 12, 14, and last 16. Okay, there you go. Now let's start it again. Here, when the age of 12, the distance is 200. Age 12, the distance is 200, so we can use here. I think. Here, let's make it this scatter. Then when the age of 8, the distance is 350. So around here. Next, when the age of 7, the scatter is 300. So it's here. 13, when the age of 13, here is 450. It's 13, 450. When the age of 9, this is 550. Age of 9, 550. Age of 10, 350. Age of 6, 100. Age of 12, 500. Age of 9, 250. Okay. Age of 11 is 450, which is here. Okay, there it is, the scatter. Next, describe the correlation. Okay, to describe the correlation, we need to draw first the base fit line. So okay, now to here 1 2 3 4 5 1 2 3 4. Okay, here the base fit line. So look at here is nearly equal before and after. So as this is not too close to each other, so the correlation is weak, positive. Draw the baseline. Okay, we draw it here for the D. Next, how old would you estimate the student if they are able to swim 450 in a half hour? So 450, let's make it straight line here. Here between here 10 and based on my line, so here is between it's quite 11 or 11 to 12 years old. So how reliable is your answer to the part A? So actually this is not very reliable because the correlation is let me write again, because the correlation is very weak. Okay, this weak, not too close to each other. Okay, next, how far would you estimate Leah, who is 15, swim and a half of hour? 15. Yeah, here is 15. So if the best fit line is around here, so we can say is more than 600 meter. Okay, I think that it is the question. Thank you.